if you have some concept depth, it is very easy to solve the questions. A small resistance called shunt resistance has to be connected parallel to the galvanometer. Hello students, this is Samson Deepak, Faculty of Physics, Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. In my today's session, I will analyze the Karnataka CET paper for the year 2006. A very simple paper. We need not use rocket physics to solve this paper. The questions are so direct. Most of them are assertions. If you have some concept depth, it is very easy to solve the questions. So we start analyzing 2006 paper. The first question, the twinkling effect of starlight is due to one of the four options given. Twinkling effect of starlight. The moment you look at the option, you feel that the correct option is total internal reflection of light. But no, the precise answer is the fourth one, which is fluctuating apparent position of the star with respect to its actual position. Andre, the stars are located at certain height from the surface of the earth. As we go away from the surface of the earth, the density and refractive index of the star decreases. Hence, the star appears to be displaced. It feels that it changes its position with respect to the actual position. Hence, there is fluctuation between the real position and apparent position of the star, which causes the twinkling of stars. And this also happens partially due to total internal reflection. But the exact answer is the fourth option, as it is displaced from its actual position. Next one. The width of the diffraction band varies. So we have the relation beta is lambda d by d, which is similar to the width of interference fringes. Will it vary inversely as wavelength? The expression shows it is directly proportional to wavelength. So this option is wrong. Directly as the width of the slit. Width of the slits represented by small d. Beta inversely proportional to small d. So this is wrong. Inversely as the size of the source. No. If you observe, beta is directly proportional to capital D, distance between the source and the slit, or what we call slit and the screen. So the correct option is the third one. Third question. See, such simple questions, little bit of concepts, we are getting the answer very easy. An unpolarized beam of light of intensity I0. There is an unpolarized light which has intensity I0. Unpolarized light ನೇನ್ ಕರಿತೀವಿ? ಆರ್ಡಿನರಿ ಲೈಟ್ ಅಂತ ಕರಿತೀವಿ. ಅದ್ರ ಇಂಟೆನ್ಸಿಟಿ ಎಷ್ಟು ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ? I0. It is incident on a pair of nickels making angle of 60 degrees with each other. Now naturally, the unpolarized light becomes polarized. So the intensity of light emerging from the nickel crystals has to be calculated. So the moment I say unpolarized light, intensity, pass axis, what is that I can refer to? Beautiful Moll's law of polarization. So what did Moll's law of polarization say? I is equal to I0 cos square theta. So this expression was referred as Moll's law of polarization. Now, here theta is given to be 60 degrees. I0, intensity of unpolarized light. So this is I0 cos square 60. Cos 60 is to makle half. So this is I0 cos square half, which is nothing but equal to I0 by 4. So this is the third option, which is I0 divided by 4. Fourth one, very interesting. You have to analyze the following graphs and identify which graph indicates one-dimensional motion. 4 ಗ್ರಾಫ್ಗಳನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ನೀವು ಆ ಗ್ರಾಫ್ಗಳನ್ನು ಅನಲೈಸ್ ಮಾಡಿ ಯಾವುದೋ ಒನ್ ಡೈಮೆನ್ಷನಲ್ ಮೋಷನ್ ಅಂತ ಹೇಳಬೇಕು. ಸೊ ಐ ಸೇ ಬಿ is the correct option here. Why? If you observe this part of the graph, the body is slowly accelerating. And in this straight portion, it is moving in the straight portion with constant velocity. Again, if you observe the top straight line, velocity is decreasing, velocity of the body becomes 0 and the particle comes to rest. Therefore, if you try to take the average slope, the slope turns out to be constant, which means it is one-dimensional motion. Next one. Very interesting. A cyclist, cycle pedal martaralla, cyclist, Olympics alle, we will consider them. A cyclist starts from the center of a circular park. One circular park ide. O is the center of the circular park, and the cyclist starts pedaling from the center O. The radius is given to be 1 kilometer. Now, he reaches the edge P of the park. Center in the start martane. He goes in this direction and he is reaching the edge P of the park. So first he is traveling along the direction OP. Then cycles along the circumference and reaches, and he cycles along the circumference. P in the circumferential motion ide, reaches the point Q. So first OP directional travel madidda, ಈಗ circumferential move ಆಗ್ತಿದ್ದಾನೆ, travels along PQ and finally comes back to the center along QO as shown in the figure. If the round trip takes 10 minutes, andre to travel this total distance O to P, P to Q, Q to O, he is taking 10 minutes. What is the net displacement and average speed of the cyclist in meter and kilometer per hour? Net displacement has to be calculated in meter and the average speed in kilometer per hour. Now, recall the definition for average speed. We told average speed is nothing but total distance traveled divided by total time taken. Alva? You have studied in mechanics, elementary mechanics, average speed is total distance divided by total time. Now, what is the total distance traveled? O to P. So first, he is traveling along OP plus along the circumference, he travels along PQ plus QO. And the time taken to travel this distance is 10. Now, therefore, S bar average speed is OP is the radius which is given to be 1 plus what is PQ? It is 1/4 the circumference of the circle. So P to Q, quarter of the circumference, 1/4 of the circumference. So circumference is 2 pi r by 4. So this is pi r by 2. Again plus QO is the radius divided by 10. So when you simplify, 2 comes to the denominator, pi plus 4 into 10. But since very clearly he says kilometer per hour into this is 20, 2 comes to the denominator into 60. 3 times. I take the value of pi as nearly 3. 3 plus 4 is 7. 7 into 3, nearly 21 kilometer per hour. Then what is the net displacement? The body is coming back to the initial position. It is getting displaced but comes back to the initial position. So it has to be 0. So the answer is 0 and 21.4. The next question. A low flying aircraft which is flying at smaller altitude passes overhead. We sometimes notice a slight shake of the picture on our TV screen. This is due to change in magnetic flux occurring due to the passage of aircraft. So when the aircraft flies at a smaller altitude, ಕಮ್ಮಿ height fly ಆದರೆ it will change the magnetic flux surrounding it. So the electron beam in the TV screen is disturbed and the picture appears to be shaked. Now, very interesting question. A beam of light whose wavelength is 600 nanometer. I consider a beam of light of wavelength 600 nanometer from a distant source falls on a single slit, 1 millimeter wide. So the distance between the slits, slit width is given 1 millimeter wide, and the resulting diffraction pattern is observed on a screen 2 meter distance. Andre distance between the slit and the screen is 2 meters. What is the distance between first dark fringes on the either side of central bright fringe? He says there is a central bright fringe. So I say this is the first dark fringe, this is the first dark fringe. On either side of the bright fringe, and I have to calculate this distance x. And please note that X is always equal to 2 times beta, distance of the first dark fringes on either side of the central fringe is 2 times beta, which means first I calculate beta, which is lambda capital D divided by small d, that is 600 into 10 power minus 9. Capital D is 2 divided by 1 into 10 power minus 3. Or this is 1200 into 10 power minus 3 goes to the numerator plus 3. Now, X is 2 times beta. So it is 2 into 1200 into 10 times, this is minus 6. So if you simplify, somewhere you get 2.4 millimeters as the answer. 24 into 10 power minus, 2.4 into 10 power minus 3, 2.4 millimeter is the answer. Physical quantity having the dimensions given. This is an assignment for you. ನಾನು ನಿಮಗೆ ಹೇಳಿದ್ದೆ ಪ್ರತಿ ಪೇಪರ್ ಅಲ್ಲೂ ಡೈಮೆನ್ಷನ್ಸ್ ಮೇಲೆ ಒಂದು ಪ್ರಶ್ನೆ ಇದ್ದೇ ಇರುತ್ತೆ. ದಿಸ್ ಈಸ್ ದ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮ್ಯುಲಾ ಫಾರ್ electrical conductivity. Now, simple again. Questions look to be elaborate. Simple thoughts, you are arriving at the question, at the answer. A battery of EMF 10 volts. There is a battery of EMF 10 volt. Internal resistance 3 ohm connected to a resistor. Current in the circuit is 0.5 amp. ಒಂದು ಬ್ಯಾಟ್ರಿ ಇದೆ, ಅದರ EMF ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 10 volts. ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಿದೆ? 3 ohms. And what is the current flowing through the circuit? It is 0.5 ampere. Terminal voltage or terminal potential difference has to be calculated. With this data given, recall the expression for terminal potential difference. We have V equals E minus I into R. Cells concept al barutte. Terminal potential difference, internal resistance, EMF anta. So the EMF is 10 minus current flowing is 0.5 into, or this is 10 minus 1.5. So this has to be 8.5 volt. So the answer is 8.5 volts. The options, sometimes it goes hayway. It is good for us because it helps us to calculate and then verify the answer. Again, a common question asked. A galvanometer has a resistance of 15 ohm. Galvanometer, the resistance 15 ohm ಆಗಿದ್ದು, and it gives full scale deflection for a current of 4 milliampere current flowing through the galvanometer. Full scale deflection ge 4 milliampere current beku. I have to convert this galvanometer into an ammeter of range 6 ampere. ಮೊದಲನೇದಾಗ ಅನಲೈಸ್ ಮಾಡಬೇಕಾದ್ರೆ I am converting the galvanometer into an ammeter. So what should I do? A small resistance called shunt resistance has to be connected parallel to the galvanometer. Voltmeter convert ಮಾಡಬೇಕಾದ್ರೆ ಹೈ ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು. ಆಮೀಟರ್ ಕನ್ವರ್ಟ್ ಆಗಬೇಕಾದ್ರೆ ಲೋ ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಪ್ಯಾರಲಲ್ ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು. ವಿಚ್ ಮೀನ್ಸ್ wherever the option says in series, that is waved off. You can see a series here, you can see a series here. Option B and D is waved off. Now I come to know the small resistance has to be connected in parallel. What is the value of that shunt resistance? So we know S is Ig into G divided by I minus Ig. This is, how much is Ig? 4 milliamperes current flowing through the galvanometer is 4 into 10 power minus 3. Resistance of the galvanometer is 15. I minus Ig. I is 6. Again 4 into 10 power minus 3. Now if you observe, so this is 60 into 10 power minus 3. This 4 into 10 power minus 3 is very, very small when compared to 6. Negligible. So I call this as 6 itself. So 10 milliamps. So the first option holds good. 10 milliohms has to be converted in parallel to convert the galvanometer as an ammeter. The electron drift speed is small. Drift velocity of electrons is very, very small. And the charge of the electron is also small. Then still, how do we obtain large current in a conductor? ಅಲ್ಲೇನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅಂದ್ರೆ, ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ತುಂಬಾ ಕಡಿಮೆ ಇರುತ್ತೆ. ಇಫ್ ಯು ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್, ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ is in the order of 10 power minus 4 meter per second. Charge of the electron is still small. Q is in the order of 10 power minus 19 coulomb. But still we can get large current in a conductor. Why? Because number of electrons or charges is very, very high in a conductor. There are 10 power 27 or 10 power 28 electrons per meter cube of a material. Therefore, we say electron density of the conductor is enormous. Therefore, the current constituted will also be large. Next one. A straight wire of mass 200 grams. There is a straight wire whose mass is 200 grams and length 1.5 meter, carrying a current of 2 amperes. Concept of current carrying conductor. Straight wire. Mass is 200 grams. Length is 1.5 meter. Current carried is 2 ampere. It is suspended in mid-air by using a uniform magnetic field. Then what will be the magnitude of the magnetic field? That means if the wire has to balance in the magnetic field, a wire a magnetic field sustain ಆಗಬೇಕಾದ್ರೆ the magnetic force should be equal to the weight of that wire. Now what is the expression for magnetic force? ಇದು charge particle ಅಲ್ಲ, ಇದು current carrying conductor. So which means BIL, magnetic force acting on the conductor, BIL sin theta. Theta is 90 degrees. So BIL should be equal to its weight, which is mg. He wants us to calculate the value of B, magnetic field, which is mg divided by IL. Mass is 200 grams. So 200 into 10 power minus 3 kg into G, according to the problem, is 9.9. Current is 2 ampere. Length is 1.5. Do the simplification. It nearly turns out to be 0.65 Tesla. So the fourth option is the answer. The next one. I have to find the value of I in this part of the circuit. ಈ ಕರೆಂಟ್ ಇದೆಯಲ್ವಾ I have to find its value in this part of the circuit. First, I'll find out the resistance in this part of the circuit. 4 ohms parallel ಇದೆ. So there, resistance in parallel 4 into 4 divided by 4 plus 4, 16 divided by 8. So this is 2. 2 and 4 are in series. So here the entire resistance is 6 ohms. Which means 4 and 6, again they are in parallel, which turns out to be 2.4 ohms. So when you draw the equivalent circuit, so Again a resistance here. So this is 2.4. This is 4 volt. This is 1.6. So if you observe here, 2.4 and 1.6 are in series. So R effective is 2.4 plus 1.6, which is 4 ohms. So the total resistance of the circuit, first E particle kandidkonde 2 ohms litto. 4 and 6 they are in parallel. So you get 2.4. 2.4 and 1.6 are in series, 4 ohms. So the main current here, I will be equal to V by R. V is 4, R is 4, which is 1 ampere. But I have been asked to find out the current in this branch of the circuit. Main current in ಕೇಳ್ತಿಲ್ಲ ಅವರು, ಈ ಬ್ರಾಂಚ್ ಅಲ್ಲಿ ಎಷ್ಟು ಕರೆಂಟ್ ಇದೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. I call this I2, I call this as I1. I2 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು. ಬ್ರಾಂಚ್ ಕರೆಂಟ್ ಫಾರ್ಮುಲಾ ಹಾಕೊಳ್ಳೋಣ, ವೆರಿ ಸಿಂಪಲ್. So I2 is main current into resistance of the other branch divided by the sum of the resistances. So this is main current is 1 ampere, 4 by 10, 2 by 5. So 0.4 is the answer. So step by step I have solved this circuit. Then I knew branch current formula. Main current into resistance of the other branch divided by sum of resistances. I have arrived at the answer, which is 0.4. Next, Gaussian sphere encloses electric dipole. The total flux across the sphere. Electric dipole andre total charge is equal to 0. Gauss theorem says flux is 1 by epsilon naught times total charge. Q is 0. Flux has to be 0. Parallel plate capacitor, exact question, previous session, look for that. The answer will be 66.6%. The next one, comb run through one's dry hair, attract small bits of paper. This is due to when we rub a comb on dry hair, the comb can attract small bits of paper because there is friction between the comb and the paper, because of which the atoms in the paper get polarized. They align themselves in one direction, so easily get attracted by the comb. The question is very, very tedious, but the answer for this is atmosphere is not a conductor. Now, specific charge of proton is 9.6 into 10 power 7 coulomb per kg. Then what will be the specific charge of an alpha particle. Specific charge andre enu first ನೆನಪಿಸ್ಕೊಳ್ಳಿ. It is the ratio of charge to the mass of the particle. Charge divided by mass. ಅದನ್ನೇ ನಾವು specific charge ಅಂತ ಕರೆಯೋದು. So he says E by m of a proton is 9.6 into 10 power 7. Then what is the specific charge of alpha particle? Q by m of an alpha particle. What is the charge of an alpha particle? 2 times E. Mass 4 times m, that of a proton. So this is half E by m of a proton. So 9.6 divided by 2, nearly 4.8 into 10 power 7. Now, the next question. When light of wavelength 300 nanometers, light of wavelength 300 nanometer falls on a photoelectric emitter surface which emits photoelectrons. Photoelectrons are liberated. For another emitter, wavelength 600 nanometer is sufficient. Then ratio of work function for the two emitters. ಮೊದಲನೇ ಸರ್ಫೇಸ್ ಇಂದ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗಬೇಕಾದ್ರೆ ಎಷ್ಟು ವೇವ್ ಲೆಂತ್ ಬೇಕಿತ್ತು? 300 ನ್ಯಾನೋಮೀಟರ್ಸ್. ಅದೇ ಎರಡನೇ ಸರ್ಫೇಸ್ ಇಂದ ಎಮಿಟ್ ಆಗಬೇಕಾದ್ರೆ 600 ನ್ಯಾನೋಮೀಟರ್ಸ್. ಆ ಎರಡು ಸರ್ಫೇಸ್ಗಳದ್ದು ವರ್ಕ್ ಫಂಕ್ಷನ್ ರೇಷಿಯೋ ಕೇಳಿದ್ದಾರೆ. We all know work function is hc divided by lambda. Phi is hc divided by lambda, which means phi is inversely proportional to wavelength. Please know this relation. Shortcuts very important. Work function is inversely proportional to wavelength. So if I say phi 1 by phi 2, inversely proportional agirodrinda 600 by 300, which is 2 by 1. So 2:1 is the answer. White light is passed through a dilute solution of potassium permanganate. What is the spectrum produced? It is the band absorption spectrum.